So here you are on the weekend and you are finally getting to your homework. Hopefully you were smart and you're doing this Friday evening and not, possibly, I don't know, Sunday night. Lovell, I'm looking at you. That's right. Okay, so here we go. This is Chapter 6, Section 7. These notes you can fill out in your course pack, page 603. You also need your calculator. So go ahead and pause the video right now, get out your course pack, page 603, and get out your calculator so that we can use both of these. So pause that, and I will continue. So example 1, f of x is x to the fourth minus 9x cubed minus 277x squared plus 1185x minus 900. This is a fourth degree polynomial. Since this is a fourth degree polynomial, this name over here, the fundamental theorem of algebra, tells me that you should have count them, 4 zeros. How am I going to find these zeros? Well, first I'm going to try to find them using my handy-dandy little calculator. So graph the polynomial to find all the real zeros. So I go to my calculator. I'm going to go to y equals. I'm going to plug in x to the fourth minus 9x to the third. Yes, I could use the cube button. Minus 277x squared plus 1185x minus 900. Biggest mistake that we can make, the easiest thing we can make sure that we don't do is make sure we don't mistype something. So I'm going to double check that I didn't mistype. Now that I've checked to make sure I didn't mistype something, I can go ahead and I can graph this. And when I graph this, I see a whole bunch of, I see a couple things, but I don't see the entire graph. So I'm going to try zoom 0. This is zoom fit. Zoom 0, zoom fit kind of makes the graph fit your window. And so notice this is what the graph is doing. The graph is starting off really low, and then it's going up and it's crossing here, but is it doing anything else? I'm not sure. So let's go back and look at my window. My x has stayed the same, my y has really changed. Let's make my x minimum, let's make it negative 50. My x maximum positive 50. Let's see what else my graph does. Aha! So I can see a lot more of what's going on here. So let's, this negative 21,000, that's way, way, way too big. Let's go ahead and make that negative 15,000. 300, let's go ahead and make this 500. Maybe we can see things a little better. What I'm noticing, what I need to be able to see, that when I look at this, I'm looking for my zeros. My zeros are going to be here, here, and I might have 1 or 2 or none there in the middle. So I need to focus more in on that point. So I'm going to go back, and instead of going negative 50 to 50, let's go negative 40 to 40. And this negative 1500 needs to go. Let's make this negative 500. I don't really need to see that low below the graph. I need to see where I cross the graph. And again, here's a better refinement. Here's 1 0. It looks like I have 2 zeros here and 1 0 here. Let's get a better refinement. Again, this is all guess and check on my part. So 40 again was too big, so let's try negative 30 to 30. Negative 500 again is too big, so let's go negative 200 to 200. I'm trying to find my zeros where I cross the x-axis, and I can see the 4 of those fairly well. So at this point, I'm going to hit second. I'm going to hit the trace button to go to calc. And I want to find my zeros. Now I'm going to stop. You can either hit number 2 and find zeros, or you can try to find the intersection. I like to use intersection. So I'm going to go back to y equals. I'm going to make y2 a 0. And I'm going to graph again. And right now, it just drew in my x-axis right here. And we don't see it where y equals 0, but it just drew it in. So when I go second trace to go to the calc, I hit number 5. First curve is that equation. Second curve is y equals 2. Let's find my guess. Let's go all the way over here and find this one first. So this is the coordinate negative 15, 0. That's my first intersection. My first is 0, my first root, my first x-intercept. So I'm going to go second trace, go to number 5, intersection again. First curve, second curve, go over to, I want this point here, hit enter for my guess, and this is the point 1, 0. Second trace to go to calc, I want number 5, intersection. First curve enter, second curve enter, go over to this other point and hit enter. And this is 3, 0. And lastly, second trace to go to calc, number 5. Enter for first curve, enter for second curve. I'm going to go all the way over to this other point on the far right and hit enter for my guess. And this is the point 20, 0. So, I don't need these graphs over here anymore. So I have my 4 points. Graph the polynomial, find all real zeros. List the real zeros. Well, this is my listing of my real zeros. Negative 15, 0, 1, 3, 1, 0, 3, 0, and 20, 0. I can say that's negative 15, 1, 3, and 20. Hint, you may need to look at a window larger than the standard window. I had to really do that. Find all the zeros. Did you find all the zeros you expected by graphing? I did. I needed to find 4. I found 4. Write the polynomial function in factored form. So in factored form, it's going to be f of x is equal to, this negative 15 is going to give me x plus 15. This 1 is going to give me x minus 1. This 3 is going to give me x minus 3. And this 20 is going to give me x minus 20. There is my polynomial in factored form. That's example number 1. So what did I do? I graphed my function. I found the zeros by doing intersection, where I could use number 2, 0. I'll do that on the next problem so we can see how that particular function works. I find my zeros. I decide, did I find as many as I needed? The answer is yes. Then I write it. Then I factor out my polynomial. There is my answer. Let's try example number 2. Number 2, this is a third-degree polynomial, so I should have 3 zeros. Graph the polynomial to find all real zeros. List the real zeros. So again, I'm going to pull up my handy-dandy little calculator. I'm going to hit zoom 6 to go to a standard window, because I like a standard window to start with on all of these. Do you have to know? But I think it's helpful. I'm going to hit y equals, and I'm going to clear my function. So now I'm going to plug in my new function, x to the third minus 6x squared plus 13x minus 12. Again, stop and make sure that you didn't make a mistake. Not finding a mistake, I'm going to go ahead and I'm going to graph this. Thinking about this, an x to the third, my leading coefficient is positive. X to the third is odd, so this is positive Egyptian. It looks like I crossed the x-axis only once. If I was to enlarge this, I would still only cross it just the once. So it says list the real zeros. So I'm going to go to second trace to get the calc, but this time I want to do number 2, the zeros. To find zeros this way, I have to find a left bound. So I'm going to move my cursor. If you look at this, it says x is negative 2.79. I'm going to move my cursor so I'm closer to that 0. Well, hey, there's a 0 right there. Well, actually, that's, yeah. So that's when x was 0, not when y was 0. My x-intercept, my 0 is when x is 0. Here's my little cursor right here. And I'm to the left of my 0. So I'm going to hit enter. I need a right bound, so I'm going to move that cursor to the right of my 0. And I'm going to hit enter. Guess, I'm just going to tap it in the middle and hit enter. And it gives me the 0 as the coordinate 3, 0. So the 0 is 3. Did you find all the zeros you expected by graphing? I should find 3 of them. I only found 1, so no. The remaining zeros must be imaginary. Use synthetic division to find a quadratic equation that can be solved by the quadratic formula. So let's use synthetic division. I want to divide out this 3. And so it's going to be x x. I put the 3 in the little box up in the left-hand side. The x cubed, the coefficient, the number in front is 1. Under the x squared, the number is a negative 6 is a coefficient. The coefficient for the x is the 13. Then the constant is negative 12. I'm going to draw my handy-dandy little line. And the first thing I want to do is drop the 1. 3 times 1 is 3. Negative 6 plus 3 is negative 3. 3 times negative 3 is negative 9. 13 minus 9 is 4. 3 times 4 is 12, and that gives me 0. Since this is a 0, it is a root, I should have a remainder of 0 every time I do this because it should divide in evenly. So the quadratic equation that I'm left with is f of x is equal to that 1 x squared minus 3x plus 4. That's my quadratic equation, my quadratic function that's left. Now I need to use the quadratic formula to solve this problem. So I'm going to use this space that I have down here. I know that f of x is equal to x squared minus 3x plus 4. So I'm going to use the quadratic formula and say x equals negative 3 plus or minus the square root of b squared, so that's negative 3 squared minus 4 times a, which is 1, times c, which is 4, all over 2 times a. As a math teacher, I want to show this step to see where my function, where my equation comes from. So negative 3 is 3 plus or minus the square root of 9 minus 16 all over 2. So this is equal to 3 plus or minus the square root. 9 minus 16, well, that's going to be a negative 7 over 2. So this is going to give me 3 plus or minus I square root 7 over 2. Those are my 2 other roots. They're imaginary roots. So list the imaginary roots. My imaginary roots again was 3 plus or minus I square root 7 over 2. List all zeros for this polynomial. The zeros for the polynomial are the points 3 plus I square root 7 over 2, and 3 minus I square root 7 over 2. Those are my zeros. Write the polynomial function in factored form. Well, I know my first factor came from this 3 up here. So this is going to be x minus 3. My other factors were imaginary, and that came from this quadratic function here. So that's x squared minus 3x plus 4. That's the polynomial in factored form. I have my 3 zeros, my 3 roots. So that's 2 examples. Let's go on to our third example and see what this tells us. F of x is equal to x to the fourth plus x cubed minus 8x minus 8. This is a fourth degree polynomial and should have 4 zeros. Graph the polynomial to find all real zeros. List the real zeros. Again, I pull up my handy dandy little calculator. I go zoom 6 to make sure I have a standard window. I'm going to hit y equals. Clear out that y1 and plug in my new equation. X to the fourth plus x. I'm going to hit the math button and choose number 3 to the third minus 8x minus 8. So there's my function. I'm going to go ahead and hit graph. And it kind of looks like a weird quadratic where it comes down and then comes up. I can hit zoom 0 to try to do zoom fit to see what happens. Realize it just makes it a heck of a lot bigger, but it doesn't show me anything else I didn't see. It only crosses the x-axis at 2 places. I'm going to go ahead and hit zoom 6 to get my original window because I think that's a better looking window. I can see that a little nicer. These were the same equations that just had a different scale on them. So I need to find these 2 intersection points. So I'm going to go ahead and hit second trace to go to the calc. I still have under y equals, I have that 0, and personally I like to do intersection, so I'm going to hit number 5 for intersection. First curve, second curve, guess. I'm going to come to this point and hit enter. And that gives me the intersection of -1, 0. So I have the point -1, 0. Bring up my calculator again. Hit second trace to go to the calc. Hit number 5 for intersection. First curve, enter. Second curve, enter. I'm going to write over to the second point and hit enter. And it's going to be 2, 0. So the second point is 2, 0. I like to write the coordinates. That's my personal preference. You don't have to, but I like to write them. So what are my zeros? List the real zeros. My real zeros are -1 and 2. Did you find all the zeros you expected by graphing? No. I should find 4. I only found 2. The remaining zeros must be imaginary. Use synthetic division to find a quadratic equation that can be solved by quadratic formula. So I need to factor out both of these 2 roots. So I'm going to come below letter I and do that. So I'm going to start with my function is f of x is equal to x to the fourth plus x to the third. Here's the thing that we need to remember. It's plus 0x squared, because when I do synthetic division, I have to have that x squared term in there, minus 8x minus 8. So when I do my synthetic division, I'm going to factor out that -1. So the x to the fourth, the constant is 1. The x to the third, the constant is 1. The x squared, the constant is 0. The x, the constant is -8. And the constant is just -8. Those are coefficients, not constants. My apologies, I've been using the wrong word. Draw my line, and the first thing I'm going to do is drop my 1. So I multiply. -1 times 1 is -1. 1 minus 1 is 0. -1 times 0 is 0. 0 plus 0 is 0. -1 times 0 is 0. -8 plus 0 is -8. -1 times -8 is 8. -8 plus 8 is 0. It factored out evenly like I wanted it to. Technically speaking, this is x to the third, 0x squared, 0x minus 8. That's what it looks like at this point. Let's go ahead and continue factoring using synthetic division. My other 0 is the number 2. I still have 1, 0, 0, -8. Again, I'm now going to drop my first number, 1. And we say 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. Negative 8 plus 8 is 0. So now I'm left with the quadratic equation of x squared plus 2x plus 4. Because the constant in front of that x squared is a 1, the constant in front of the x is a 2, the constant in front of, or the coefficient in front of the x squared is 1, the coefficient in front of the x is 2, and then the constant is 4. So that's my quadratic function, x squared plus 2x plus 4. So the quadratic equation, f of x is equal to x squared plus 2x plus 4. Use the quadratic formula to solve. Again, I'm going to go down below my other work. And down here, I'm going to say that x is equal to negative b, which is negative 2, plus or minus the square root of b squared. So that's 2 squared minus 4 times a, which is 1, times c, which is 4, all over 2a. Excuse me, a here is 1, so 2 times 1. Remember, underneath that square root should be a negative number because I'm expecting an imaginary solution to this. So this is x is equal to negative 2 plus or minus the square root of 2 minus 16 over 2. So this is negative 2 plus or minus the square root of negative 14 over 2. I can't reduce anything. The only thing that I can do is negative 2 plus or minus I square root 14 over 2. There is my two imaginary roots. Negative 2 plus or minus I square root 14 over 2. So I come back up here, list the imaginary zeros. That was negative 2 plus or minus I square root 14 over 2. List all zeros for this polynomial. Well, the zeros were, first I had the number negative 1, then 2. Then I had negative 2 plus I square root 14 divided by 2. And then I had negative 2 minus I square root 14 over 2. Do you have to write those separately? No, you don't. Why am I writing them separately? Because I'm looking at the idea of having my 4 zeros, my 4 roots. I want to be able to see 4 different things. Can you write that as 2 plus or minus I square root 14 over 2 and know that that's 2 roots? Yes. Roots and zeros are the same. Write the polynomial function in factored form. So this is going to say that f of x is equal to, my first root is negative 1, so this is x plus 1. My second root is 2, so this is x minus 2. And then the last part, again, is this quadratic equation part, and that's going to be x squared plus 2x plus 4. Those are my notes. Those are my answers to these 3 examples. Hopefully that makes sense to you. We will work more on this in class, and I will see you then. Have a good day.